Ever pondered why anxiety seems more prevalent in young women? We're about to step into the world of brain chemistry to unravel this mystery, guided by the latest research findings from the University of Surrey. It's a fascinating journey that takes us deep into the workings of the human mind, shedding light on the delicate balance of two crucial brain chemicals, gamma-aminobutyric acid, often shortened to GABA, and glutamate. This balance, it appears, may hold the key to understanding anxiety in girls and young women. GABA and glutamate serve as the yin and yang of brain chemistry. As young women mature, GABA, a calming brain chemical, increases, while glutamate, known for its role in boosting brain activity, decreases. It's a delicate dance of chemicals, with each playing a vital role in the ebb and flow of brain activity. But what happens when this dance is out of sync? The researchers from the University of Surrey suggest that the equilibrium of GABA and glutamate in a specific region of the brain known as the dorsolateral prefrontal cortex may be a vital indicator of anxiety levels. In essence, glutamate propels brain activity, while GABA acts as a brake. Anxiety, often characterized by impaired rational thought, might be intricately linked to an overactive braking system in the brain. The insights from this research not only help us understand the underlying mechanisms of anxiety, but also point towards potential treatment avenues. By focusing on the balance of GABA and glutamate in the brain, we might be able to spot and stop anxiety disorders early, particularly in young women. This study is a beacon of hope, illuminating the path towards more effective treatments for anxiety. By unraveling the mysteries of brain chemistry, we're empowering girls and young women to take control of their mental health, opening the door to healthier, more fulfilling lives. So buckle up and join us on this exciting journey. Stay tuned as we explore these intriguing scientific revelations. Two brain chemicals are at the heart of our discussion: GABA and glutamate. These two play a pivotal role in our brain's function, each with a unique job to do. Let's start with GABA, or gamma-aminobutyric acid, if you're feeling scientific. This brain chemical is essentially a calming agent. Think of it as the brain's natural chill pill, helping to reduce neuronal excitability throughout the nervous system. It's like the friend who always knows how to calm you down when you're feeling anxious or stressed. On the other hand, we have glutamate. Unlike GABA, glutamate is the life of the party in the brain. It's the primary excitatory neurotransmitter, responsible for sending signals between nerve cells, and under normal conditions, it plays an important role in learning and memory. It's like the friend who encourages you to step out of your comfort zone and try new things. Now here's where things get interesting. These two brain chemicals have a sort of yin and yang relationship. While glutamate stirs up activity, GABA works to slow things down. They maintain a delicate balance that is critical for the brain's overall health and function. But what happens when this balance is disrupted? When GABA and glutamate aren't in harmony, it can lead to a range of neurological disorders, including anxiety. In fact, recent studies suggest that an imbalance between GABA and glutamate may be at the root of anxiety, particularly in young women. The research suggests that as young women mature, GABA levels increase, providing more of that calming effect, while glutamate levels decrease, meaning less of that excitatory influence. This shift in balance could potentially lead to an overactive braking system in the brain, contributing to the feelings of anxiety. So, what happens when the balance between these two chemicals is disrupted? Let's find out. This sets the stage for a deeper dive into the science behind anxiety and the potential for new treatment avenues that directly address this chemical balancing act. A recent study from the University of Surrey offers some answers. This groundbreaking research delved into the complex world of brain chemistry, aiming to uncover the relationship between anxiety in young women and the balance of two critical brain chemicals, gamma-aminobutyric acid, or GABA, and glutamate. The study was meticulously designed and executed, involving a total of 81 participants. The participants were divided into two distinct age groups. The first group comprised 49 participants aged between 10 and 12 years, while the second group consisted of 32 participants aged between 18 and 25 years. This age range was specifically chosen to provide a comprehensive understanding of anxiety development during the crucial stages of growth and maturation. The researchers employed a sophisticated brain imaging technique known as magnetic resonance spectroscopy. This non-invasive method allowed them to measure the levels of GABA and glutamate in different areas of the brain. Through this process, They were able to observe how the balance of these chemicals shifted as the participants matured. In essence, the researchers were not just looking at the brain, they were listening to its chemical conversations. They were paying close attention to the dialogue between GABA, the calming chemical, and glutamate, the one that boosts brain activity. By doing so, they hoped to decipher the complex language of brain chemistry and how it might relate to anxiety. What they discovered was fascinating. As young women mature, the levels of GABA increase, acting as a kind of brake on brain activity. At the same time, the levels of glutamate decrease, reducing its role in stimulating brain activity. This delicate balance, it seems, plays a pivotal role in the development of anxiety. These revelations offer a promising new direction in the quest to understand and treat anxiety in young women. By focusing on the balance between GABA and glutamate, researchers hope to develop more effective treatments for anxiety, empowering young women to lead healthier, more fulfilling lives. The findings from this study are nothing short of eye-opening. The findings suggest a delicate balance between GABA and glutamate could be key to anxiety levels. The University of Surrey's groundbreaking study unveiled a fascinating revelation about the interplay between two crucial brain chemicals, GABA and glutamate, in young women. As young women blossom into adulthood, the levels of these two chemicals shift, potentially setting off a chain reaction that leads to anxiety. Imagine GABA as the calming, soothing melody in your favorite relaxation playlist, and glutamate as the fast-paced, heart-pounding beat in a racing game. As young women mature, the soothing melody of GABA grows louder, while the fast-paced beat of glutamate fades into the background. This might sound like a peaceful transition, but it's this very imbalance that could be the root cause of anxiety. But it's not just about the imbalance. The study also introduced us to a concept known as the brain's overactive braking system. Picture your brain as a car. Glutamate is the gas pedal, propelling the car forward, sparking brain activity. GABA, on the other hand, is the brake. It steps in to slow things down when they get too hectic. But what happens when the brakes are applied too often, even when they're not needed? The car, or in this case the brain, struggles to move forward. This overactive braking system is what many believe to be the cause of the impaired rational thought often seen in anxiety. These findings have opened up new doors to understanding the inner workings of anxiety. It's like we've been given a map, and for the first time, we can see the path anxiety takes through the brain. This discovery could be a paradigm shift, changing the way we approach anxiety in young women. By understanding the delicate dance between GABA and glutamate, we can develop targeted interventions that address this balance. We can fine-tune the soothing melody and fast-paced beat in our brain's playlist, and maybe, just maybe, help young women everywhere find peace and balance within their minds. These insights not only shed light on anxiety, but also open the door to potential treatments. But what do these discoveries mean for the future of anxiety treatment? This question takes us to the heart of the implications and future directions of this groundbreaking study. The study's findings underscore the importance of the delicate balance between GABA and glutamate in the brain. This balance is like a tightrope walk, and when it's off, it can lead to anxiety. It's a fascinating revelation that paints a clear picture of why anxiety develops, particularly in young women. But it's not just about understanding why anxiety happens, it's about what we can do with this knowledge. The study's revelations could pave the way for targeted interventions that specifically address this imbalance in the brain. Imagine for a moment a treatment that doesn't just blanket the symptoms of anxiety but goes to the root cause. A treatment that could restore the balance between GABA and glutamate, essentially correcting the overactive braking system in the brain that Dr. Johnstone spoke of. That's the future this study points towards. It's an exciting prospect, to say the least. It's about moving away from a one-size-fits-all approach to treating anxiety and towards more personalized, effective treatments. Treatments that don't just manage anxiety, but that could potentially prevent it from developing in the first place. Of course, we're not there yet. There's still a lot of research to be done, a lot of questions to be answered, but the direction is clear. The goal is to provide more effective treatments for anxiety, treatments that can help young women not just cope, but thrive. And that's the most important implication of all. It's not just about understanding the brain or developing new treatments. It's about empowering young women. It's about giving them the tools they need to lead healthier, more fulfilling lives. By understanding our brain chemistry, we can empower young women to lead healthier, more fulfilling lives, free from the burden of anxiety. That's the promise of this research. That's the future we're working towards.